long time ago, in a forest, there's a flower, a grass, and a tree. One of them got invited for the Olympia ice skating. Who is it? The answer is the flower. Why? Because 花式溜冰. In this video, we are going to talk about 花式自殺. Alright, just kidding. I'm not encouraging any sort of suicide. This is just an imaginary question, okay? But it's very interesting. Think about this. If you somehow have a gun and you somehow is on the moon, how can you shoot a bullet? How fast does it need to be? If you try to shoot forward and try to get the bullet go back around the moon and strike the back of yourself, how fast does it need to be? Alright, sooner or later it should be, right? Because if you think about the planet itself, if you try to shoot not so fast, then it's going to be like this, just go onto the ground, and then onto the ground, onto the ground, and then eventually you should be able to shoot at the right speed, which hit yourself. But of course, you can't do too fast, because if you do too fast, then it's going to be like something like this, which can never return. So it has to be the exact speed that you are shooting. So how fast does it need to be? Go and set up the equation yourself, find the parameters that you need, pause the video now.
2,000 years later.
If you watch a previous video, this shouldn't be hard for you. Let me show you how we can do it. So once again, we have to use F equals to ma, applying to a circular motion, because that is exactly what we just mentioned for centripetal force and centripetal acceleration. So the force that maintaining the bullet moving, and by the way, we are assuming no air resistance. Okay, that's why that's one of the reasons why we want to do it on the moon. There's a tiny bit of air, but then we can assume there's no air at all. Anyway, so for the force, it's going to be the gravitational force of the bullet itself. So that's going to be big G, the m of the moon, by the way, and then the m of the bullet itself over the r squared. This r is talking about the radius of the moon. Some of you may be thinking, hey, then should I account for the height of the person, right? Because for the moon, you are technically standing on it, and it should be slightly greater than the radius. You could, but I'm pretty sure that your answer eventually would not matter, because if you try to search the radius is like 1,700 km. So unless you are a few kms long, it's not going to affect anything. So just ignore it. Okay, and so the other side of the equation, you may use m again for the bullet, and for a, it depends on what kind of format you want. But since we are trying to calculate how fast, that must be containing the term v. So I'll probably use v squared over r. Again, r is the radius of the moon. And so the rest should be easy, that we just have to cancel out the m, so it doesn't really matter what kind of mass of the bullet needs to be. It works on any sort of bullet basically. And then the r can also be cancelled out for one time, and you just have to find out the values of these things. So v squared would equals to, which is these numbers, and eventually you should be able to find out v equal to 1,678.84. So I guess that is the speed that you need when you launch the bullet. Unfortunately, the fastest speed of bullet ever made is only 1422 meters per second. It's not enough to reach our requirement for the speed. So our dream is now broken. Because I'm dreaming about the new Starwar. Think about this, if you can really do this on the moon, and from the old Starwar movie, you always see those Jedi and blah blah blah, and they're using their lightsaber and then the gun, and then just shoot each other, pew 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 pew. But then think about this is so boring. Think about this. What if you could shoot a bullet not directly to your enemy, but you shoot it behind? You can go around the bullet and maybe you can hit on target. That would be so cool, right? That's the dream that we need. I guess we can't get better Star Wars movie then. However, if you want to have more video like this one, please hit the like button now and subscribe to my channel. I'll see you again in the next video. Bye.